So yeah, hello Alicante. It's great to be back here. This time for the lightning version of the presentation I got in a performance case study. Olá. Estou muito feliz de estar aqui um ano mais. I am MATHEUS ALBURQUERQUE. I'm a staff software engineer at Medallia. I'm a GDE in performance. I love this conference, so huge shout out to the organizers. And you can find me everywhere as Y the Combinator, by the way. I have to say though, I have a way longer version of this presentation where I can get way more in depth in all the details and etc. So do check that out if you want to hear more. So a little bit of a preamble on why I wanted to present this in first place. So there's this post, it's called Silent Engineers, and it's a really interesting thing. I recommend you check out, but I like how it starts. The author goes with, why browser in Hacker News? I sometimes get the feeling that every developer out there is working for FANG, as there are always posts from those people doing some hyped stuff. And he goes on, but let's be straight, that's like 1% of all the developers out there. The rest of them are just lurking and coding with the language of choice and being content with it, be it Fortran, COBOL, Perl, or PHP. So that's kind of what this talk is about. Realities of industry and maintaining legacy code bases and bringing technical lift in this legacy code bases. So unfortunately, I won't be talking about cool stuff like React 19 or Astro or all of that. Luckily enough, we had a lot of people who made great presentations about that already and more to come. What we're going to be talking about is a tale of modernizing your dependencies, also splitting code and dynamically loading it, working with React, and doing all of that while targeting different browsers. And since I'm here to talk about realities of my industry, this is my company, Medallia. We are a customer experience company, and I work on the surveys team, so that's basically collecting signals from people on their opinions on something. So first part, modernizing dependencies. This is kind of where we were. We had React 15, Webpack V1, and Node 10, and yeah, wow. One thing that a lot of people don't know though is that some of these libraries, they do get smaller from one major to another. So React, for example, is 30% smaller if you compare the bundle size, the bundle footprint of 15 versus 16. But so migrating would be a good start, right? But then you have some challenges. For example, the prop types package. Prop types in React 15, they're part of the React package, but React 16, they're a whole separate package. We were happy that there's this tool called JS Code Shift by Meta, and JS Code Shift is a tool that runs transformation scripts over one or more JavaScript files, applying transformations to them. And JS Code Shift plays really well with different code mod packages that you have out there, including the React Code Mod. So React Code Mod contains a bunch of transformers that you can just start using with JS Code Shift. And one of them, for example, is the prop types package. So that's where we started. But gotcha, we had to maintain two versions in parallel. We could not simply revamp the whole code base and ship it to production, even though we had, for example, sandbox environments and etc. We still had to hide this behind a feature flag that could be gradually enabled for different customers. So that's where our code generation journey actually started. So just to recap, we had to support in parallel different versions of developer experiences like Node.js, Webpack, Babel, etc. We also had to support different versions of the things that were running in the client, like React itself. And last but not least, we have to support different strategies for bundling all that code. So that includes different configuration files for Webpack, Babel, and etc. It's better if we can visualize. So we had this monorepo with multiple packages. And let's focus on package A for now. That was the key part of the thing. And we went from this model to this. And basically here we still have A, but now it's this legacy package. And that's the default model that's still served to the vast majority of the customers. And that's where active development also happens. So new features, bug fixing, and etc. And that's the code that is actually pushed to the repo, so included in Git. And that's the code with the legacy dependency, so React 15, Webpack 1, Node 10, and so on. And here we have this wrapper that we call Next, but not to be confused with Next.js. It's just the next iteration of it. where we had configuration and scripts. So this, everything bundled inside here was hidden behind a feature flag, and that included the more modern versions of dependencies, so Node 18, Webpack v5, React 16, and etc. And most of the code that was in there were code transformers or automation scripts or the new configuration files targeting the new versions of Bubble and similar in Webpack. And that's also the parts of code that we didn't manage to code generate using JS code shifts and AST transformations. So some unit tests and some functional tests. And then we had the final next bundle, and that was generated at build time, so that meant either locally or via a Jenkins pipeline. And that included all the React components, utilities, and business logic. And this code was never pushed because it was generated in build time. So we also had 1,000 lines git ignore that was also automated. So a fairly simple version looked like this. So we had a bunch of texts copying things around, moving them, renaming them, and running the AST transformations. Diving a little bit more into the transformation thing, a hello world of a JS code shift transformer would look like something like this. So you get a file, and then you have JS code shift API, and you have a bunch of utilities. For example, here, I'm finding all the declarations that are full, and I'm renaming them to bar, and then you return this as source again. But this is, again, just a hello world. You can build anything more complex. And it plays really well with this tool called AST Explorer. So if you ever wondered what kind of representation is generated from your JavaScript or React or JSX code, check this out. It's super helpful when building your custom transformers. And at the end, we had a huge series of transformer groups that consisted of a nice label to represent what they're doing, the files that we were targeting, and a JS code shift transformer associated to it, so dozens of these. That was the first part. Second act, code splitting. So I guess most of you are familiar with lazy and suspense. Who has used lazy and suspense together for code splitting? Oh yeah, so yeah, half the audience. So that's like pretty standard way these days of doing code splitting, and that's where we started, and we got really, really good results because basically our starting point was a place where a survey taker would download the entire all the kinds of possible questions, even though you were answering a survey with just 3 or 4 different question types. So results were really good. People started taking surveys and only downloading the actual questions used in that survey. But the gotcha here is that, as you can imagine, and as just like any other performance optimization technique, this doesn't come for free. So in our case, so side effects matter what happens. In our case, we do have a way to allow customers to write custom JavaScript and custom CSS to customize the look and feel and experience of their surveys. And one regression we had was basically the customizations that these clients had written before were breaking because they were trying to access down elements that were still not there because they were dynamically loaded. So we had to think a little bit more about that. And then third act, allying production builds with Preact. So Preact is super popular, and I want to raise your hands thing, but I guess a lot of you are familiar with. If you're not, Preact is this smaller alternative to React with very, very stable compat base. And this is kind of the numbers we got just by swapping the production build to be built with Preact. And of course, not include code splitting. So as you can see, out of the box, a lot of savings. Again, some gotchas. So there are a few issues that could appear depending on your dependencies and things like this. I myself noted that Preact wasn't really playing well with dynamic imports on top of React Lazy and Suspense. So our fallback was loadable components that added to the final bundle footprint just about 2 kilobytes. So the trade-off was totally worth it. Then part 4, all of that while targeting different browsers. So I don't know about you, but I always get surprised when I check what kind of browsers are actually visiting my app. Because you see things like BlackBerry's, Samsung proprietary browsers, and even PlayStation console. So yeah, we should ship polyfills. But at the same time, you don't want to ship like polyfills and legacy JavaScript to modern browsers. So you do have to think about this balance. There are a couple of different techniques, and you can use services like polyfill.io, you could use Babel, use built-ins, and there's one resource that is on top of this ES modules in the browser, so that's where we went. So we went with module/no module detection in runtime. So an oversimplified version of this script looked like this. Basically, you check if the browser supports or not, or doesn't ES module, and then you load one version or not on top of it. And there's a bunch of nuances about that to be discussed, but I have to say that a couple of months later, I was at least happy that I didn't go with polyfill after the supply chain attack that happened. So, yeah. A couple of results from this. Of course, these are just two of the PRs, and you can see like those are kind of poster boys of PRs you don't usually want to do, but so a whole ton of changes. Thankfully enough, unit tests were mostly passing. After that, our huge suite. We had a modern and a legacy bundle. So the modern bundle had a 37% smaller bundle if compared to what we had before. And for legacy browsers like Internet Explorer, we had a 25% reduction. And the line was basically drawn on top of ES module support. That, as of now, that counts for basically 95% of browsers worldwide. And when we correlated that with our user base, that meant that only 0.2% of people that were using Internet Explorer or similar would get the legacy browsers, so vast majority of people got faster experiences. And faster experiences in terms of Web Vitals, so most of them were improved. But not only this, other metrics around visual timings, you can see when the feature flag is on and off, they also improved. And things like visual progress and etc., feature flag on versus off, also improved. So yay. Just before I go, last minute of closing thoughts. I harp on this string a lot, but I really think that understanding, at least at some level, the internals of the tools you're doing, like React, JavaScript, etc., really helps you come up with clever solutions and abstractions to some problems. And I think that this whole migration upgrade tool on top of JS Code Shift and AST explorations is a good example. And that's not a new thing. A couple of years ago, we had languages like Elm and PureScript investing a lot on performance optimization based on that. Nowadays, we have Svelte, Solid, and even React investing in compiler work to optimize for performance. So yeah, there's a lot of room to be explored there. The second thing is, yes, you have to ship polyfills for all the browsers your users could be using, but at the same time, it's a bad idea to ship all of them preemptively. So do think a lot about how you're going to do this. And of course, the cliche is true. There's no silver bullet. So think about your metrics and think about solutions that best suit your metrics. Experiment a lot, do a lot of A/B testing and all of that. That is it. It was kind of rushed, but muchas gracias for having me again, Alicante. Thank you. All the links are there.